Today's lecture is about FET and its types. FET is a type of transistor which is a miniature semiconductor that regulates or controls current or voltage flow, in addition amplifying and generating these electrical signals and acting as a switch or gate for them. FET stands for field effect transistor, which is a type of transistor that uses an electric field to control the flow of current through a semiconductor material. FETs are made of three regions of semiconductor material: the source, the drain, and the gate. The source and the drain are connected by a conductive channel, which is controlled by the electric field produced by the gate. FETs are P-type and N-type channels. Field effect transistor can be used as a voltage control device in electronic circuits, and a voltage placed at the gate controls current flow from the source to the drain of the transistor. Field effect transistors have a very high input impedance, from several megaohms of resistance to much larger values. FETs draw very little current from a circuit's power source. Field effect transistors come in two main types: JFETs and MOSFETs. Its symbol is given here, where D is representing drain, G represents gate, while S represents source. JFET stands for junction field effect transistor. It is a type of transistor that operates by controlling the flow of current through a semiconductor channel using an electric field created by a reverse-biased p-n junction, similar to the gate in a MOSFET. In a JFET, the current flows between two terminals called the source and drain, which are connected to the ends of the semiconductor channel. The channel is made of a single piece of semiconductor material, such as N-type or P-type silicon, with two regions of opposite doping that form a p-n junction at the center. The gate of a JFET is formed by a third terminal that is connected to the p-n junction. When the gate voltage is negative with respect to the source, a depletion region is formed around the junction, which acts as a barrier to the flow of current through the channel. By varying the gate voltage, the width of the depletion region can be changed, which in turn controls the resistance of the channel and the amount of current flowing through it. JFETs can be of two types: N-type JFET and P-type JFET. The primary difference between the two types of JFETs is in the polarity of the semiconductor channel. In an N-type JFET, the semiconductor channel is made of N-type material, and the gate terminal is connected to a P-type region on either side of the channel. When a negative voltage is applied to the gate with respect to the source, the depletion region widens, reducing the cross-sectional area of the channel and decreasing the current flow. In a P-type JFET, the semiconductor channel is made of P-type material, and the gate terminal is connected to an N-type region on either side of the channel. When a positive voltage is applied to the gate with respect to the source, the depletion region widens, reducing the cross-sectional area of the channel and decreasing the current flow. In both types of JFETs, the current flow through the channel is controlled by the width of the depletion region, which in turn is controlled by the gate voltage. N-type JFETs and P-type JFETs have similar characteristics, but they are used in different applications depending on the requirements of the circuit. JFETs are commonly used as amplifiers and switches in electronic circuits. They are known for their simplicity, high input impedance, and low noise characteristics. However, JFETs are less commonly used than MOSFETs due to their lower gain and more limited range of operating voltages. MOSFETs, or metal oxide semiconductor field effect transistors, are a type of transistor commonly used in electronic circuits. They are voltage-controlled devices that allow for the amplification and switching of electrical signals. The basic structure of a MOSFET consists of a metal gate electrode separated from a semiconductor channel by a thin insulating layer of oxide. When a voltage is applied to the gate, an electric field is generated in the channel, which controls the flow of current between the source and drain terminal. In an N-type MOSFET, the channel region is made of N-type semiconductor material, which has an excess of negatively charged electrons. The gate voltage applied to the metal gate electrode attracts electrons to the surface of the semiconductor, creating a conductive channel for current to flow between the source and drain terminals. In a P-type MOSFET, the channel region is made of P-type semiconductor material, which has an excess of positively charged holes where electrons are missing. The gate voltage applied to the metal gate electrode repels holes from the surface of the semiconductor, creating a conductive channel for current to flow between the source and drain terminals. MOSFETs are widely used in many electronic applications, including power amplifiers, voltage regulators, and digital circuits. They offer several advantages over other types of transistors, including high input impedance, low power consumption, and fast switching speeds.